Hi everyone, my name is Hrvoje. As they already mentioned, I come from Croatia. I work in a company called Five, but for the last year I worked exclusively for Reactive International, a music streaming service, and before that I worked 1 year for Real Networks Austria. So I don't know, maybe you've heard of that. Okay, let's begin. As most of you are probably aware, the name of my presentation is Going Reactive with RxJava. But first, a couple of disclaimers. Number one, I will not give you any vague or confusing definitions of what RxJava is or should be. If you want that, then please visit Wikipedia. Number two, this is not a summary of the RxJava API. If you want that, then please visit RxJava API. They really did a good job there, and it's good, really. Okay, instead, in the next 30 minutes, we'll focus on the concepts and the ideas that drive RxJava. Okay, so all we need to know for now is that RxJava is a Java library, and you can use it to make your apps more reactive. Okay, let's begin. But before we can see how RxJava can make our apps more reactive, first we need to define what does it actually mean for an app to be reactive. Okay, so Reactive became a buzzword. You know, this is reactive, that is not reactive. But being reactive isn't anything new. I mean, we've always done reactive apps. I mean, if your app waits for an input of 2 integers and then it multiplies that numbers, then it's a reactive app. Why? Well, because it reacts to an input, so by its definition is reactive. Okay, so being reactive isn't something new. But how reactive is your app? How does it handle pressure? How does it handle failure? Okay, so these are the important questions. So basically, here we need to define a set of requirements that each good reactive app should meet. And in comes His Majesty, and this is not working. I was supposed to say, okay, the Reactive Manifesto. Okay, in the last few years, this Reactive Manifesto became very popular as a source of a set of requirements that every good reactive app should meet. Okay, so let's see what are those requirements. According to this manifesto, reactive app should be: number one, it should be message driven. So all the communication among your components goes through asynchronous messages. Okay. Then we should be resilient. So we stay responsive in the face of failure. So no blue screen of that, no 500 internal server errors or stuff like that. We're always responsive. Okay. Also, we should be scalable. So we respond if we have 200 requests or 2000 requests. We are always responsive. And the last one is responsive. Okay, right now you're probably wondering, but wait, he already said responsive twice. And yes, I did, but it's not the same if you respond to a request in 2 seconds or in 2 minutes, okay? So this requirement tells us that time does matter, okay? So we should always respond in a timely manner. If we put all of this in a diagram of some sort, we'll get something like this, okay? And as you can see, at the bottom of everything, we have message-driven communication. And actually, this loosely coupled communication will help us achieve all of the other requirements. You'll see that later. But this is a Java track. Most of us here are Java developers, I suppose. And Java is primarily an object-oriented language, okay? So let's see how object-oriented paradigm answers these requests. And it goes something like this. Okay, so green is good. Yellow is not so good, but it's okay, and red is bad, okay? And now, before you start throwing stuff at me, I'm not saying you can't make good reactive apps using object-oriented paradigm. You can, of course, and I'm sure all of you are doing that. I'm just saying that it's a little bit harder to do that with object-oriented paradigm, okay? Why? Let's discuss. Message-driven communication. Okay, fine. Most object-oriented apps are event-driven. Fine, we'll just pack our events into messages. Okay, that's not a problem, right? Okay, scalability. Now we have 2 problems here. Number one, our state and behavior is joint objects, okay? And number 2, our state is mutated, okay? So it's very hard to do parallel execution on an object if its methods are not side effect free. Long story short, you'll eventually get into a lot of trouble, of course. Resilience. Well, for me, the problem with resilience is that error handling is up to the client, okay? So resource cleanup, try catch blocks, everything is up to the client, you know, and client is lazy, you know, the client doesn't want to think about the worst case scenario. All they want to do is make their happy path work, and that's it. But when the error happens, and it will occur, of course it will, that's when you're in a world of trouble again. And the last thing is responsiveness. Well, I think that's okay. I think that object-oriented apps are pretty responsive most of the time, okay? I think that's, it is yellow, but it's quite okay. Okay, so now let's see how RxJava can help us with all of this, okay? First we'll tackle message-driven communication. So we need to switch from an event-driven model to a message-driven one, okay? Sorry for the okay. So as we said, everything is message, even errors, everything is a message. So each component in our system can be a producer of these messages and can be a consumer of these messages. So for example, a producer can be, I hope everyone is seeing it here, producer can be some UI component, some remote service, some scheduled job, whoever. A message can be, again, anything. It can be an event like mouse click, mouse move, or something like that. It can be computation result. It could be a query result. Like I said, whatever. Everything can be packed into a message. And a consumer can be whoever subscribed, okay, whoever wants to listen. And here I would also like to introduce the notion of streams of messages. Okay, so each time a producer is sending something to consumer, it's called a stream of messages. So if it's one message, it's a stream of one message. If it's n messages, it's a stream of n messages. But each time it's a stream. So now let's see how we can make these streams of messages with RxJava. In order to do that, RxJava introduced two abstractions. One is observable, which is a representation of the message producer, and the other is observer, which is a representation of the message consumer. Since it's pretty hard to say observable and observer in the same sentence and not get confused, trust me, I tried, I'll continue using producer and consumer. Sorry, but it's really it was a trial and error. Okay, so when our producer wants to send a message to our consumer, what will he do? Okay, well, basically he will call the consumers on the next method. And in that method, as a parameter to that method, it will pass this message to a consumer. And if a producer has n messages to send to its consumer, it will call the onNext method n times. And that's it. That's how it works. And once the producer is done sending messages, it's got no more messages to send, then it's producer's responsibility to call the consumer's own completed method, and thus notifying the consumer, okay, I'm done, I have nothing more to send to you. I'm done, okay. Or, if an error occurs, in that case, it's again producer's responsibility to call the consumer's own error method, and thus notifying the consumer that an error on the producer occurred, and again, that sending is finished. So in both cases, on completed and on error are the terminal messages, terminal calls. There's nothing after that, okay? Now let's see how we can, and once again, producer is observable and consumer is observer. Now let's see how we can make our observables. Well, first of all, RxJava comes packed with lots of predefined methods for creating observables. There's more than 200 methods, you know. There's a lot of them. Here I just put a few of them just as an example. But if you're really interested, then please visit the RxJava API. So for example, we have, I don't know, observable.from, in which you put in some list of items, and then each item of that list will be a message in your stream. Or you put, for example, or you will use .interval method, and then you create an observable which will periodically push long values down the stream, or range for integers and stuff like that. There's really a whole bunch of methods. But The real power comes in from observable.create method. Why? Well, because with that method we can create our own observables. How do we do that? Well, actually it's quite easy. All we have to do is call the observable.create method, and as an input parameter to that method we give a lambda expression, and in that lambda expression we basically implement the behavior of our observable. So for example, as you can see here, we can call some remote service to get the data, then we can push that data downstream using the onNext method, and once we're done we can just call the onComplete and inform our consumer, our observer, that we're done sending. Or if something horribly wrong, or if something goes horribly wrong, then that's why we have this try catch, and in the catch we'll call the onError, and that's it. If we want to send multiple messages, then for example we'll just put in a while loop here and we'll do the onNext, I don't know, 10 times, whatever we like. Okay, so this onNext, onCompleted and onError methods, we are calling them on the subscriber object. I haven't mentioned subscriber object yet. Basically subscriber is observer, so onNext, onCompleted, onError, plus a few other methods. Okay, that's all I need to know for now. Later we'll come to that. We'll come to the subscriber later. So for now, subscriber equals observer plus a few other methods, and that's it. Extended observer, let's say. Okay, so now we created observable. Now let's see how we can consume that observable. Consuming observables. Well, at its core, it's quite simple. All we have to do is call the subscribe method on our observable instance, and nothing more. As an input parameter to that method, we give in an instance of the observer interface. And this observer interface, as we know, has three methods: onNext, onError, and onCompleted. And we do whatever we want in those methods. That's it. As you can see, this is a pre-Java 8 example. If we want to use Java 8 and lambdas, then it will look something like this. 3 lambda expressions for 3 methods, and that's it. Pretty simple. Okay, so now let's review our diagram again. So in order to handle message-driven communication, we introduced observer as a message consumer and observable as a message producer. Now let's tackle scalability, shall we? First we need to think of how do we approach this problem. Do we scale up? So buy some fancy, expensive hardware? No, I don't think so. That's too expensive, yes. Okay, so then we need to scale out. We need to buy a bunch of cheap commodity hardware. And what will this give us? Actually, well, this will give us a lot of cores and a lot of memories. So the desired characteristics of our new system would be that program logic should execute in parallel. Why? Well, because we have a bunch of cores, we want to use them. And that data immutability is allowed / encouraged. Why is it allowed? It's allowed because we have a lot of memory, so why not use it? And it's encouraged. Why? Well, because it's pretty hard to do things in parallel when you are mutable. So it's better to be immutable. And the answer to that is functional programming. I know I can see the desperation in your eyes, but functional programming really is the best fit here. It's not, don't kill the messenger, it's not my idea. Why functional programming? Well, first of all, because in functional programming, state is handled transparently. What does that mean? Well, as you probably are aware of, in functional programming, objects are immutable. So, for example, if you have a function, and this function receives some object as an input, and the function wants to change the state of this object, what will it do? Well, it will create a new instance of that object. So it will basically just create new instance and with the new desired state, and output that instance out to return that instance out to the function. So we can see that functions are side effect free. You know what you are giving into the function, and you know what you are getting out. And there's no side effects. And because of that, it is pretty easy to change them together. So you just chain a bunch of functions together, and the output of one function is the input to the next one. When we apply that to our RxJava world, so our data manipulation, in order to to manipulate data, we'll create a bunch of observable FP style methods. Okay, that's for changing the data and manipulating data. And for state change, we'll use streams. So each change of state will be a new message in our stream of messages. Okay, so no data immutability, just new messages each time we want to change state. Okay, as you can probably imagine, there's a bunch of composable methods that come predefined with RxJava. For example, like I said, there are more than 200 methods in the observable class alone, so I don't intend to go through all of them. For example, there are methods used for content filtering, you know, like filter this based on that parameter and stuff like that. There are methods for time filtering, like throttling and some intervals and stuff like that. There are methods for data transformation, you know, for example, apply this change for each message in the stream. And of course, there are methods for stream composition. So for example, you can have 2 streams of messages, and then using merge operation, you can merge them together and create a new stream with both messages from those 2 streams in it. And important thing here is that each of these methods creates a new stream. Okay, so when you apply the method, you'll get in return you'll get a new stream, and this allows you to chain those streams, to chain those methods together. If you look at an example, it looks something like, let's say, something like this. So at first we have a stream of 9 elements, 9 messages. So that are 9 integers from 1 to 9. Let's say that first we apply a skip while method, which will ignore all the elements until an expression is satisfied, and this will give us a new stream of only 5 elements. Then we can, for example, apply the take method, which will take only the first 3 methods of the stream and create a new stream with only these 3 elements. And then, for example, we can apply a reduce method, which will actually accumulate these 3 elements into 1. And at the end, we are given a stream of only 1 element, and we can subscribe to that stream and do something with the result. I don't know, whatever we want to do. And this is how all these methods work. Okay. So now let's review our diagram again. So in order to tackle scalability, we introduced a bunch of FP-style observable methods. That's for data transformation. And for state, we introduced transparent state using messages of the stream. So each new state is actually a new message in the stream. Okay, so we stay transparent. Now let's tackle resilience. When the system fails, and as I said before, it's not a matter of will it fail. It will, of course, it will fail, but it's just a matter of when will it fail. With classic OOP, the client has to do resource cleanup, try catch, and stuff like that. With RxJava, all the client has to do is implement the onError method. And this is very convenient. Why? Well, because the observer interface that we as a client need to implement comes with the onError method, which we must implement. Okay, so we need to do it right away, right from the beginning. So basically what we did here is we made error a first-class citizen. Why? Because we need to think about errors right from the beginning. Okay, it's not just happy path, we need to think about errors also. Okay, great. But the thing is, sometimes, you know, the problem here is that the onError is a terminal state. So once our producer pushes the onError, calls the onError method, that's it. This producer will not send any more messages. Sometimes we want to recover from this error. Okay, how do we do that? Well, just for these kind of scenarios, guys in RxJava created a few handy methods. Let's say it like that. So, for example, there are more methods than I mentioned here, but I just wanted to show you a couple of them. So, for example, we have a non-error return method, which will actually mask this onError call to our consumer. It will just mask that call. It will intercept that call, and instead of this onError call, it will produce one. It will push one more message down the stream, and then it will call the onComplete. So basically, onError is masked, and instead we have one more onNext, and one more on complete, of course. Or, for example, we have onError resume next, resume next method, which will again intercept this onError call, and instead of that, it will start pushing messages from some other stream down our stream, down to our consumer. So, for the example of this would be when you have, let's say, you have two producers. One is very fast but not so resilient, and the other is slow but it's very resilient. So most of the time you would use this fast one, well, because it's faster, of course. But when this one fails, then you want to seamlessly switch to the other one, to the slower and more resilient one. And with onError resume next, you would do just that. Or, for example, we have the retry method, which will, in case our producer fails, it will just start everything again. You know, it will create new instance, restart the producer, and start everything again. Okay. And this is all I have to say about errors. Okay, so in order to tackle resilience, we made error a first-class citizen. But unfortunately, you cannot see it here. But resilience, the color of resilience here is yellowish greenish, something in between. Okay, why? Well, because making error a first-class citizen is definitely a good start. It's a great start. And these handy methods for error recovery are also great methods. But sometimes this is just not enough. Okay, especially when you work in distributed environments. Because there you don't have classical errors. You have latencies, lags, and stuff like that. And just this is sometimes not enough. There are libraries like Hystrix, which Netflix works on, which can help you with that. But this is not part of RxJava, so I cannot say that RxJava is good. You need to use, in order to improve resilience, you need to use additional libraries. But this is a good start, let's say it like that. Okay, and one last thing, now let's tackle responsiveness. Or let's get responsible. Notice that V here is not a typo. This is the new word I'm trying to get going. Okay, so first we need to be responsive to our client. Of course, we need to be responsive to our client, and also we need to be responsible to our system, to our resources. First, okay, let's talk about responsiveness. Well, we already improved scalability and resilience, and that must help our responsiveness. But until now, we haven't talked about asynchronous execution. I'm not sure if you noticed, but RxJava out of the box is single-threaded. Okay, so it's blocking, it's synchronous. What does that mean? Let's see that in an example. So let's say we have. Can you see that? Okay, I hope you can see that. Let's say we have our main thread, and on that main thread we have our main method, okay? And at one point, we'll call observable.subscribe. Okay, what will happen after that? Well, immediately our main method will get blocked, and the observable.subscribe method will start executing on our thread. And of course, for example, this subscribe method can, let's say, call some remote service. Then it will call our onNext method. Then our onNext method will start executing. Then it will call the onCompleted method. Then our onCompleted method will start executing. And only after all of this is done, then will our main method start executing again. So as you can see here, this is a pretty big line. And most of the time, our main method was blocked. Okay, sometimes that may be fine, but I suppose that a lot of times we don't want to do that. So now let's see how we can improve on this, or let's get asynchronous. Okay, so just for this case, RxJava comes with a few handy methods. The first one is subscribe on method, and basically this method. With this method, we can define on which thread do we want our producer to be executed. Okay, and on the other side, we have the observe on method, with which we can define on which method we want our consumer to be executed. So subscribe on is thread for our observer, and for our producer, and observe on is the thread for our consumer. So producer, consumer, we can define 2 threads for that. And as you can see here, as an input parameter, these methods take a scheduler instance. Schedulers are RxJava's implementation of task schedulers. Okay, and RxJava comes with a few predefined schedulers. So the first one would be immediate. Basically, this scheduler will block your current thread and just start executing. So it's not very useful. Then you have the new thread scheduler, which will create a new thread and then start executing tasks on that new thread. Then you have the trampoline scheduler, which will actually in-queue work at the current thread. So after current work on the current thread is done, then this new work will start executing on that same thread. And of course, we have 2 thread pools. One is pool of threads for input-output tasks, and the other is pool of threads for computation tasks. Okay, so now let's see how this works in an example. Again, we have our main thread, we have our main method, and again we are calling observable.subscribe. Only this time we are also defining the subscribe on and the observe on methods. Okay, so what will happen here? The moment we call this subscribe method, a thread from a pool of input-output threads will be fetched, and our observable, our producer, will start executing on that thread. We can just presume that there was at least one available thread in the pool of input-output threads. Let's presume that it was. Okay, so our producer, our observable, so is running on that new thread, on that thread. And at one point, our producer will call the subscriber.onNext. What will happen then? Well, again, RxJava will retrieve a thread from a pool of computation threads, and it will start executing the onNext method on this computation thread. And the same goes for the onComplete method. And as you can see here, during all that time, our main method on our main thread was unblocked and kept running whatever she wanted to. And that's how we tackle asynchronous execution. Okay. Okay. So now we've seen how we can be responsive. To our client. Now, how we can be responsive. Now let's see how we can be responsible. Okay. So for me, at least for me, being reactive isn't just about doing something fast. It's actually about not doing it at all, or to be more precise, to do only what's necessary. Okay, so to do only the tasks and the jobs that really need to be done, and nothing more. You know, why? To save resources, of course. Okay, so how can we do that? How can we be responsible to our system? Well, the first thing is our observables. Our producers, okay? So I'm not sure if you noticed, but our observables do something only when someone's listening. Okay, so we can create our observable. We can chain a bunch of methods to that observable, and that is all fine, that is all great. But none of this will start executing until we call the .subscribe method. Okay, so none of this will execute until somebody is listening. There is a thing called observables, but we won't talk about that. For now, let's stick to this. Okay, so observables run only when someone is listening, and thus we save our resources. Okay, so that's the first thing. And the second thing is the unsubscribe method. Okay, so let's say we have some producer, some observable, which periodically retrieves data from, let's say, database and pushes this data down the stream. At some point, maybe we are no longer interested in the data. Maybe we don't want to listen to this producer anymore. It would be very wasteful if that producer continued consuming our resources, right? Why? I mean, why if the data is not needed? And just for that case, we have the unsubscribe method. Okay. There are actually 2 flavors of unsubscribing. The first one is unsubscribing from the outside. How do we do that? It's quite simple. As you can see, when we call the subscribe method on our observable instance, we receive a subscription object. And using that subscription object, we can just call this subscription.unsubscribe. And That's it. We dismantled our producer-consumer stream, and that's it. It doesn't work anymore. Okay, or we can unsubscribe from the inside. How do we do that? Well, it's quite simple again. Again, we have our subscribe method on our observable instance. Only this time, we are not creating new observer, we are creating new subscriber, okay? So I already told you something about the subscriber. I said that subscriber is observer plus a few other methods. And one of these methods is actually the unsubscribe method. And so at one point, we don't want to listen to the messages anymore. We'll just call the unsubscribe. And that's it. We have dismantled the stream. Okay, so now let's visit our diagram once again. So in order to be more responsive, we introduced asynchronous execution, and we also introduced resources on demand. Well, I mean, asynchronous execution is also related to scalability, but I had to put it somewhere, and this looked prettier. And that's it. But you get the picture, okay. And so as you can see now, we have one, let's say, pretty green and pretty nice diagram. Considering that scalability and resilience was green before, and responsiveness was yellow, and now it's all greenish/yellowish. I think that this is an improvement against the first version. Okay, and that's it. Thank you for your time. Q's and hopefully some A's. I don't know. I'll try to answer something. Okay, sure. I'm sorry?
How does RxJava compare to Java 8 streams?
How does it compare? Well, you can say that it's an addition to Java 8 stream. I've seen cases of implementing. You can let's say pack Java 8 stream into RxJava object or stuff, and then you can use it together with the other observable methods on the RxJava. So you can say it's extension addition Java streams. Let's say something like that. You can use it together. That's it.
Did you use RxJava together with any frameworks that rely only on thread locals? Like, for example, when you do database transactions?
I mean, database. You mean RxJava and database transactions?
Well, yeah, or anything that relies on thread locals. So, because here you always have
Yeah.
stuff is
Well, I did, before this presentation, I did some research on transactions and RxJava, and I mean the problem here is that by definition, transactions tend to group work together and then execute everything as one, and on the other side, RxJava tends to dismantle everything into small functions. You know, so the problem there, unfortunately, they are not very compatible. There is RxJava JDBC library. I must say I haven't tried it, but I saw some examples of it, and it's well, basically somebody packed a transaction into an observable instance, and then they added a couple of methods like from select. No, there are tries. Somebody tried it, but unfortunately, the problem is that they are really apart in their core definition, let's say it like that. But that is a good point, and that will definitely have to be addressed. But RxJava is mostly for let's say some middle layer, application layer. Not so you wouldn't do a transaction in RxJava. Instead, you would call some service that would do some transactional behavior. Okay. Well, if I have to choose between the two, I would probably choose the second. So it's, I mean, you can do it. It's the basis of RxJava are streams of data, some wherever you can put some UI events or whatever. But okay, maybe coordination / transformation of data would be more on the course of what RxJava tries to do. But even these observables, they are so broad in their definition, you can use them anywhere. I mean, you can take a list of strings, and just because you like RxJava methods for manipulation, you can just pick. I mean, you just tell observable.from and put a list in, and then you have 200 methods with which you can transform your list. So, you know, the application is quite broad, you know. Even if you don't like to write procedural, even if you just don't like to write procedural code, you can use RxJava if you want.
It seems like a good replacement for the observer pattern.
You mean, well, it is, they said it's an observer 2.0, so it's a new, it's addition again to the observer. Okay. That's it. Thanks for coming.